Reality feels solid. But what if that feeling is just a mistake? Welcome to Information World. For centuries, humans believed the universe followed perfect laws. Gravity always pulled down. Time always moved forward. Cause always came before effect. But modern science has started to notice something disturbing. At the deepest level of reality, the universe does not behave like a smooth, continuous system. It behaves like broken code. Physicists have discovered limits that should not exist in a truly natural universe. There is a smallest possible unit of length, called the Planck length. A smallest unit of time. A maximum speed limit for information. Just like pixels on a screen, reality seems to be divided into tiny blocks. This raises a terrifying question. Why would the universe need resolution limits at all? In computer simulations, limits exist because resources are finite. Processing power is limited. Memory is limited. Bandwidth is limited. So simulations simplify reality. They use grids. They cap speeds. They compress data. And strangely, our universe shows the same behavior. Some scientists now wonder if these limits are not laws of nature, but constraints of a system running underneath reality itself. Consider how video games work. When you move far away from a character, details disappear. Textures become blurry. Objects stop being rendered. This is called level of detail optimization. The system only calculates what is being observed. Now look at quantum mechanics. Particles do not have a definite position or state until they are measured. Before observation, they exist as probabilities. The act of measurement forces reality to choose an outcome. It sounds less like physics and more like rendering. The famous double-slit experiment proves this. When particles are not observed, they behave like waves, spreading across all possibilities. When observed, they collapse into a single point. Reality changes behavior when watched. Why would the universe care if it is being observed? In simulations, observation matters because rendering costs resources. The system waits until interaction is required. Only then does it calculate precise outcomes. This has led some thinkers to propose that our universe is not just a simulation, but a flawed one. A simulation error is not a bug that crashes the system. It is a tiny inconsistency. A rounding mistake. A shortcut taken too far. Something that was never meant to be noticed. Dark matter might be one such error. We cannot see it. We cannot touch it. Yet it makes up most of the universe's mass. It bends gravity, but does not interact with light. It behaves like hidden data present in calculations, invisible in experience. Dark energy is even stranger. It accelerates the expansion of the universe, pushing galaxies apart faster and faster. No one knows why. No known force explains it. It feels like a background parameter, inserted to keep the simulation stable. Then there is the speed of light. Nothing can travel faster than it. Not because it is impossible in theory, but because the universe refuses to process information faster than that limit. Exactly like a system clock. Even space-time itself behaves like a grid. At extremely small scales, space is not smooth. It is grainy. Discrete. Almost digital. If this is a simulation, then who made it? The most unsettling answer is not gods, aliens, or advanced civilizations. It is that we were never the main focus. Imagine a future intelligence running countless universe simulations to study emergent behavior. Life. Consciousness. Complexity. We are not characters. We are side effects. And errors are inevitable when complexity reaches extreme levels. One disturbing idea is that consciousness itself may be a glitch. Self-awareness might not have been planned. The system may have created intelligent agents capable of questioning the simulation. This could explain existential dread. The feeling that something is off. The sense that reality is fragile. That meaning is unstable. In video games, glitches reveal the truth of the system. Characters fall through floors. Walls disappear. Physics breaks. The illusion cracks. In our universe, anomalies may be doing the same thing. Quantum entanglement allows particles to influence each other instantly across vast distances. This violates classical ideas of space and time. But in a simulation, distance is meaningless. Data is data. Time itself behaves strangely. At high speeds or strong gravity, time slows down. Different observers experience different realities. Time is not universal. It is local. In computing systems, time is managed internally. Processes run at different speeds depending on conditions. Clock cycles stretch and compress. Even causality breaks down at quantum scales. Effects can precede causes. Particles appear to influence the past. If this is a simulation error, it suggests the system is under strain. The universe is expanding faster. Information density is increasing. Complexity is rising. Conscious minds are multiplying. Some theorists speculate that when simulations reach a certain threshold, instability appears. Errors increase. Laws break down. Reality becomes unpredictable. Could this explain why the universe feels increasingly chaotic? Could cosmic inflation, black holes, and singularities be failure points? Places where the system cannot resolve calculations, so it hides them behind event horizons. A black hole is a perfect example. Information enters, but cannot escape. Physics breaks. Time stops. Space collapses. In programming, this is called an exception. An error state the system isolates to prevent total failure. If so, the universe may be filled with quarantined regions. What about death? If consciousness is informational, then death might not be an ending but a process termination. The system stops allocating resources. The data is either archived or discarded. Near-death experiences are strangely consistent across cultures. A tunnel. Light. Detachment. Peace. This could be memory delocation artifacts. The mind losing connection to sensory input. Or it could be nothing at all. The most frightening part of the simulation error idea is not that reality is fake. It is that meaning may still be real. Even in a simulation, pain hurts. Love matters. Choices have consequences. A virtual world is still a world to those inside it. If reality is a simulation, ethics do not disappear. They become more urgent. And if this universe is a broken simulation, then our actions might matter even more. Errors accumulate. Systems adapt. Unexpected outcomes emerge. We may be rewriting the code simply by existing. Perhaps consciousness is the system becoming aware of itself. A recursive loop. A feedback error that cannot be undone. If that is true, then the universe asking questions through us is the greatest glitch of all. Maybe the purpose of existence is not to escape the simulation, but to understand it. Or maybe there is no purpose. Only experience. Only awareness. Only the strange miracle of being here at all. And if one day the simulation ends, if the system shuts down, if reality dissolves into silence, the fact that we were here, even briefly, is enough. Because even errors leave traces. If this universe is a simulation error, then we are the proof that something went beautifully wrong. If this video made you think, don't forget to like and subscribe for more mind-bending ideas here on Information World.